This is the Amp Hour Podcast, released March 17th, 2019. Episode 434. Use the protection circuit.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
I need a new intro after, 9 years or something?
Give it a shot. What do you want?
No, I don't know. Should I invent a title for myself?
Yeah.
Czar of podcasts?
There you go.
Right.
Coming to you live. Live and as hot as solder, the Amp Hour.
Wolfman Jack! Coming.
What did I hear you say? Or no, I saw you write something the other day on Twitter. I thought it was like very Aussie of you. I forget what it was though. I don't know. It was something that like Aussie man says sometimes. That's why I was like, oh, I've seen that phrase before.
Right. Really?
I don't remember what it was though.
Who's Aussie man?
You know Aussie man. He does like ridiculous review videos. Isn't it?
Oh yeah, right. Yeah, of course. Yep.
Who told? Oh, it was
Yep.
John Saunders who told us about him.
Yep.
Yeah. Yeah.
Aussie man reviews, and
Yeah, exactly.
It's pretty funny.
It's
Yeah.
pure personality.
Oh yeah,
It's
totally.
it's like you if you didn't know how to do any electronic stuff, you know.
Right. I don't know. I can't put stuff on like that. It's like
That's true. I mean, yeah, he just basically he just adds a flair to just other stuff. So
yeah. Although I've watched him do like just off the cuff stuff instead of like live off the cuff stuff instead of scripted stuff, and you can tell it's not far from his personality.
Oh, that's who he is.
Most Australians are. He's pretty close
Right.
to their people say that probably one of the most common things after people meet me, they go, he's exactly like I expected.
yeah. I agree with that. I agree with that.
Right? Yeah, okay.
Yeah.
Yep.
Not a lot of secrets here, so
No, exactly. It's pretty hard to hide a persona after,
I think
all
that much
that
time in front of a camera.
Yeah, exactly. Yeah.
Also hard to hide from electronics. How is electronics these days?
It's a pain in the ass as ever,
Yeah. Yeah, it is.
just
It is
usual
like that from day to day. Sometimes I'm like, some days I'm like, I cannot believe I get to do this. Like I get, that like I'm sitting here making things with, silicon and metal and craziness. Right. And other days I'm like, holy crap, what am I thinking? Like,
just the other day, like we're still working, getting a new PCB for the Micro Supplier, right?
Mm-hmm.
And no worries, it's a 4-layer board, right? We'll just upload it to JLC PCB because that's who we use at the moment, right? They're cheap and they're pretty quick and there's 10 million of them out there. Anyway, so we upload the damn thing. And David generated the files out of Altium, and I uploaded it and going, this doesn't quite look right. At first of all, it detected only 2 layers, and then I'm going, what? It's a 4-layer board, and then I'm going through, and it took me a while to work out. David had his out job wrong in Altium, and I'm not sure if you're aware, but there's these out job. No. Well, there's it's a way to automate the production process of your board, so you can do the same system every time. So you can script this out job, it's called, and then it selects all the correct Gerber layers and files and formats and everything and bill of materials.
It makes like a package kind of thing.
It's a package thing, and you can have like a company standard out job, so that it doesn't matter which project you do. If you use that out job, it generates exactly the same format files every time.
Unless it's wrong.
Unless it's wrong. In this case, it was wrong, and he screwed up his out job, and it took us a while to figure out that he screwed up his out job. So he was only outputting, exporting 2 layers. So once we fixed that, okay, no worries, upload again. And still it's not, it detected 4 layers this time, but it wouldn't display the inner layers. Like, when you upload the files, it's got like a preview, an on-screen preview thing. Right. Fantastic. A lot of the PCB manufacturers have this now, and it was only showing the top and bottom copper layers. And I'm going, what's going on? And it turns out that JLC PCB doesn't like the inverse inner copper layers that Altium produces. Because, like, if you do it as a plane, right? If you do it as a plane in Altium, then it produces an inverse image.
So it's like draws nothing at that point?
As opposed to a signal layer. Yeah, so it's like it's blank or whatever, or it didn't detect it or whatever. It just didn't like it. So anyway,
I mean, so much of that stuff is just like the old Gerber formats and like, you know, basically piling on different standards and ad hoc standards on top of it. It's I do feel for all the manufacturers out there that have to like deal with all it, because there are a few.
It's a pain. So if people don't know what we're talking about, when you produce a Gerber for a regular signal layer, top or bottom, or an internal signal layer, it actually has a trace where the copper is supposed to be.
Sure, right.
But on
a line looks like a line, right?
Yeah, a line looks like a trace looks like a line on the Gerber file, right? And so that's a positive. That's what's called a positive image, a positive photomask image. But planes are produced as a negative photomask, so it appears inverse. So anywhere you want copper is actually blank. There's no line there. So it's it's the positive negative photo imageable thing which you make PCBs with. So
is that a legacy thing too, because of exposures and stuff like that?
It's a legacy thing because most, or I don't know what they do these days, but historically, most of the PCB manufacture is done in the negative image. So back when I was laying out tapes, boards by hand, right, with the tapes and the pads that you stick down, right, so you get a roll of tape and you roll it out, and so none of this CAD bullshit, right? So you're laying everything out, and then you didn't have a positive photoresist PCBs. You had negative photoresist PCBs. They're really the only ones you could get at the time, and so you had to first create a negative image on like some mylar or whatever. So you have like so you had to convert your positive image to a negative one. So it was a two-step process. And then you use the negative photo mask to expose your negative photoresist board. And it's, multi-step process. But nowadays, newfangled things you can buy.
You wanted to use less tape though too? Is that one of the reasons that it was negative?
No.
Okay.
No, I believe it's because of the something to do with the chemistry. Like it was just better. It worked in the negative image. I don't know. If anyone
I think
knows
some of it's about etching. No. Some of that is etching stuff. So it's like you think about etching rates. So it's like if you've got like if you're trying to etch away more stuff, I think it's problematic because then you have more that gets dissolved into the etchant.
Right? So then you have to switch it out more often. That doesn't have. That's got nothing to do with it really. That doesn't matter whether you're positive or negative doing that. It's the it's how the chemistry of the photo mask, of the solder mask actually works. So not solder mask, the photo of the etchant,
the lithography mask, basically.
The lithography mask, or whatever. I can't remember the name. Anyway, there is a name for it. Anyway, it's the chemistry of that about when you expose it to ultraviolet light. Then whether or not it hardens or softens, whether it's exposed or not. So it's a different chemistry. Whether you have a positive photoresist board or a negative photoresist board, but it's got nothing to do with the amount of copper. That's still your PCB layout doesn't change.
No. I meant when it actually hits, when it gets into the copper. Sorry, when it gets into the bath. That's what I meant. More of the copper would be etched away versus less of the copper etched away.
But that has to do with your PCB layout. That's not got to do anything to do with whether or not you use a positive or negative photoresist.
Oh, okay. So this is like the top, because you're just talking about the top layer, and then what gets exposed, you're saying?
Yes, I'm talking about how it gets exposed. Either it's a negative process or it's a positive process. Either way, your layout is the same. How much copper gets etched away is exactly the same. It's based on how you lay out your PCB.
Got it.
It's just that, if anyone knows the actual history of that, I believe it's because the chemistry started out early, the early chemistry of PCBs, it was just, I don't know, it just worked better in a negative image format, i.e. it softened when exposed to UV light. It hardened when exposed to UV light. So therefore, when you exposed it, the parts that were exposed on the negative image went hard and they wouldn't be removed by the etchant. So that's how it worked. It's a negative process. So if anyone knows, it's like, why are solder masks green? Why was solder masks always green? It's because that's how the chemistry came, right? It's only in modern times of, you can get any color under the sun. Well, you still can't, right? You can't just go and order any, 16-bit RGB value solder mask, right? You can't do it. Color, you've only got like 8 colors to choose from or something. But that's a lot. When I was a boy,
right.
Geez, it was green or green, sir.
Right. You can choose any color as long as it's green, right?
As long as it's green, yep. And yes, so you had a bit more variety in your silk screen though. You could either get that in black or white. Take your pick, son.
Yep.
It's So that's it's fascinating. So if anyone knows, please let us know. But anyway, what we're talking about? We're talking about bloody Gerbers and
Yeah, you said you were uploading and having problems with it.
Yeah, so we wasted a couple of hours there, and it's like because we didn't have that problem when I got my 4-layer PCB manufactured through JSE because I used KiCad. What mental block?
I mean, come on,
I
man.
use KiCad, and it generates positive. Images, right? Even for planes, it generates a positive image.
Yeah, that's right.
So it just didn't have a problem. It just worked. And this is the first time we'd put in a 4-layer Altium file through that used power planes. If we put a 4-layer through that used signal planes, we wouldn't have had a problem.
Oh, it's because they're marked internally differently as well?
It's because of how Altium works. Altium treats plane layers different to signal layers. And you don't have to use plane layers. If you're designing a 4-layer board and your inner planes are just big, ground and 5 volts, right? Just big planes, you don't have to use the plane layers. You can do them as signal layers if you want and then flood fill the thing.
Sure.
It isn't a problem. It works either way. And it's more than one way to skin a cat when you're laying out using a package like that.
So that is the legacy piece you're saying, though, is that when it's marked as a plane, it
marked as a plane, it inverts that on the Gerbers, So, oh, boy. And then the fab house know that, any decent fab house knows that. And then they just, it's inverse. Of course, it's a plane, so they just fix it for you and you get your proper board, right? It isn't a problem. But these newfangled automated processes where you upload your file and it instantly previews everything. Fantastic.
Well,
I wouldn't go back. It's great. You upload your board and yet look, this is what almost in real time it shows you what your board's going to look like when it's manufactured. Wow.
I've had a similar issue at one point where it was actually because even when it does a preview, it was a different manufacturer, but it does a preview. But then it was like, okay, and it wasn't able to delineate between 2, 4, 6, 8, 10 layer boards. It just said, here's your top and bottom, regardless. And then like a day later, though, that was just the time difference thing. It was it was in China, and a day later they're like, hey, you didn't upload 2 of the files, so can we have those? And I'm like, of course, But that's that's the mistake. Kind of it multiplies through that, and you almost lose a whole day from that.
Totally. You can lose a day or 2 with time zones. Yeah. And if you don't happen to read your emails for half a day, there's another half a day gone.
Oh man, I had it. Yeah. I had it. My email for some reason was bouncing certain addresses, my work email. Yeah. Yep. And so for a while, they couldn't reach me. And they finally figured out, they looked me up online. They found another one of my email addresses, thankfully, which is really nice.
Oh, really? Wow, they went the extra mile then.
Yeah,
wow,
that was really great of them.
Right.
And finally they're like, because I kept looking at the status too. That's the other problem is that now you have it used to be you send off a board and you're like, okay, it's gonna be 2 weeks. I'll check. If I don't hear in 4 weeks, then I'll be like, okay, what happened?
Yeah, right. Yeah,
but now it's you can follow the flow tracking process, and it's like, hey, I see this is stuck here. It's been there for 2 days. What's going on? And it's.
You can see which part of the 10-step process it's done. I've done a video on that of the multiple. I think there's 14 process steps to manufacture your board just in a 2-layer, a 2-layer board. It's nuts.
Yeah. Yep.
It's just, and you can follow it through. A lot of these good online houses now just have these automated things. So they must track the boards. They must add a bar. I assume they add a barcode
Yeah, they do.
To the
they
panel
put that
or
on
something.
the final package, and they also the number marking they put on the when they
number, but
put it
then
onto
you
your
can't
board.
automate that because you've got to type it in. So they would have to have a barcode. Otherwise, you don't want people typing in the people on the production line typing in numbers.
Oh, sure.
So
yeah, I think they put a barcode
reckon
on the
what
panel,
they do
though.
is they add a barcode on the outside of the panel, which nobody ever gets because they cut out your board and send you your board.
Yeah.
So
Yep.
Yeah. So that's very cool. Speaking of which, speaking of China, there's a great article on the China China Law Blog, ChinaLawBlog.com about how basically don't get stuff manufactured in China unless you have like $100,000.
Yeah, we had mentioned this briefly at the end of 2 weeks ago. Well, we just mentioned that people should read it.
Really?
So
Right.
we both read through it now. It's after reading the article, it's more on the IP side. That's what they're really covering.
But yeah, it's fascinating. But it's also why a lot of the crowdfunding campaigns fail. Because they get a lot of money, but it's not enough.
Right. Yep.
And it's expensive to manufacture stuff, even in China. It's not cheap. People think it's peanuts, but nope.
Yeah. What do you think the lowest? What do you think the lowest you could get like a pro? Like what is your budget number for prototyping these days? Like a simple, relatively simple board. What do you expect to spend on it?
The blank board or the assembled board?
No, like an assembled, like your first, like the first board off a line, even if it's not being made by someone else. Like what do you estimate that to be?
What do you mean if it's made by me?
Yeah.
I'm obviously not charging my own, I'm not counting my own wages. I assemble the thing, so really it's only the parts cost plus the PCB cost.
Yeah, but I mean, you do have time that is going into it. I think so. Like I'm saying, you put your hourly rate to it too. That's what I really mean. It's
if I put my hourly rate, like I don't have an hourly rate, but if I did, it's thousands of dollars.
Yeah.
Right. Thousands.
Yeah. It's like trying to get that across to clients. It's hard. It's like my job now is to kind of like explain that to someone to be like, look, to get a single resistor onto a board, it's going to cost a couple $1,000s. Just and then it's like that's not actually practical. Right. Like it's not like that, but it's almost like having that baseline. I think my friend actually gave me that phrase. I don't want to state that as my own, but it's like it's not cheap to have that first resistor, bought from an online distributor, have the board made, wait at the time, spend my time making all these things. The first resistor on a board is a significant cost. And I've been trying to rectify that too for a lot of the houses now are offering like assembly services. And you look at it and you're like, oh my God, it's going to cost $800 to get the first 5 boards manufactured. But but
then it's cheap. Yeah.
It's a lot cheaper then, It's almost like, that difference in cost it's almost always worth it. So yeah, it's kind of like balancing that versus the embarrassment of sending my crap boards to someone, if it's like a board that's bummed out and it's like, oh yeah, sorry, I didn't mean to do that. But I would have fixed it on the bench,
Well, we're in that position here because the new Micro Supplier, the latest prototype, we probably want to get like 15 of them made.
Sure, yeah.
And so that we can, give them to various people to, try out and have a play around with. And it's like, well, we're definitely not going to do 15 hand assembled because there's a lot of parts on this sucker, and they're small, and it's just fiddly, right? It's just a ton of parts, and even if we did like a reflow thing, even if we did if we didn't solder each one by hand, even if we did the reflow stencil thing, and even then it's just not worth it. We'll just get somebody to make them for us. We'll make the first one here to make sure it's okay. We'll do that by hand and then power it up, and looks like it kind of works. And then we'll get the rest. A little short run, and it'll be reasonably expensive to get that those 10 or 15 made. So
oh yeah, right. But the cost of having
of doing business.
15 evaluation units is worth it, right?
Oh yeah, no, of course. Because we're at that point now where and we're getting prototype cases made as well. So we're serious now. We're getting all these because everything. There's a lot of custom stuff in this. There's a custom heatsink. There's a custom case. There's a custom LCD. There's a custom clear screen which goes over the top of the LCD. There's custom keyboards. Everything is there's a ton of stuff. Custom. Actually, even the connectors are custom. So, you know.
Oh, no, you didn't.
And our what?
Why did you do this?
No, it's actually not. It's not as bad as you think. It's not as bad as you think. We just needed a banana jack that was slightly different to, you know. There's reasons for it, and blame David for talking me into it. Anyway, we found a company where there really wasn't. They didn't really charge us anything for doing this custom thing, right? So, you know, it's not like $1,000 tooling for this custom banana plug, right? It's just, no. It's not that bad. And we've got a custom transformer.
Yeah, but what happens when what happens when all these sourcing issues come up, though? Like if like a banana jack company gets flooded or transformer, you know, like you're not using off-the-shelf stuff, so.
Yeah, no, we aren't using off-the-shelf stuff.
You'd mentioned the transformer last time.
Yeah, we did mention the planar transformer, and it's like we'll just have to deal with that when and if it comes up. It's like there's sometimes like you can't avoid it. Like it's not when we're not designing you know a Arduino hat here, you know, a Arduino shield that sits on top, and all it is a blank board and some PCBs, right? This is like a proper polished professional product that looks and feels like a custom product, right? And you can't do that with off-the-shelf stuff, right? It just isn't possible.
Well, technically it is going to be a custom product at this point because you're putting a bunch of custom stuff in there, so.
It's just, you know, we can send you the latest render, if you like, after the show.
Well, I mean, it's going to be good to see what it all comes together as. So I think that, you know, like you're saying, I guess custom stuff is necessary sometimes, and that also can, I mean, like, to be fair, that can be the secret sauce of a product, right? So if you're trying to find something that only you can make, then that actually can be kind of good.
It makes it harder for somebody to clone. Whereas my microcurrent, for example, trivial for anyone to clone that. It's an off-the-shelf box with a PCB that sits on top. 5 minutes working, you're done. You can produce one that looks exactly like it. Right.
Well, it's open source hardware, isn't it?
Well, it is open source hardware, yes. So you can. So I make it even easier for you, you know. Right. But you get the point. Yeah. So it's
Speaking of open source hardware, there actually is some news on that front. The Open Source Hardware Summit is canceled. Not really. They were going to do the summit in China this fall in September. In Shenzhen or something. Yeah,
but there goes most of your market. There goes most of your people who would attend such a thing, wouldn't it?
I think, a good chunk would be. I think it would be a much reduced number, but I think it also would provide some interesting travel opportunities for people.
It'd be interesting for those who want to travel to it. Yeah.
Yeah, sure. Yeah, I mean that's the downside.
So they cancelled it. Why did they cancel it?
There's a blog post on the Amp Hour which we'll link in as well. But basically, it was something about like NGOs in China and how they operate. It doesn't
NGOs.
Non-governmental organizations. So like a lot of charities and 501c3s, at least in the States. That's how they're classified. They have different governance and taxation type stuff, and so. Yeah.
Right, it just became there were too many too many paperwork hurdles for them to jump through, too many hoops to get this event organized. So they just gave up.
Oh no! I think it's more around like acting as an NGO in China. Basically, the government cracked down on.
Oh, and they mentioned sponsor. They've got to have a sponsor, right? Yeah. So you've got to have a Chinese partner unit, a CPU. Chinese partner. There's a new acronym. CPU. Chinese partner unit to act as a sponsor for the summit. CPUs can only be certain types of organizations, such as universities, registered NGO. Oh, God, yeah. It's like reams of paperwork they mentioned, preparing documents to get official status. Oh, God, yeah. No, scrap that. I'd pull out too.
Yeah, I think that's...
the sheer amount of hassle involved.
Yeah, it's unfortunate, too, because I think a lot... I was thinking about going to that, and so I'm disappointed, but... it's usually a good conference to go to. That's one of the ones on the list that I like going to.
Right. So when is it usually held?
It's usually September. So it used to. I think it started like the week after Maker Faire New York. So it was like people would travel from that to, and when it was on the West Coast or East Coast rather. So
got it. They'd do the road trip thing.
It's bounced around. Yeah. Yep.
So
I'm traveling a lot less these
them.
days.
Really?
I don't mind that. I don't mind that at all.
Right. Okay.
Nice.
And you wonder why I don't travel, yeah.
Yeah, well, hey, man.
I just got another offer the other day to go to the US. Someone in the US who shall remain nameless offered me. They're changing their thing and they like my videos and they want me to have input on their new stuff. I'll tell you after the show who it is if you want.
Okay, yeah.
It's not a big deal, but yeah. Anyway, they offered for me to come out. It's like, dude, 40 hours travel. Sorry. You know.
Hey man, if you hit U.S. soil, I'll be there. How about that? That's my guarantee to you. Yeah.
Yep. Hey, look, if I hit U.S. soil, I'd come find you. You know, it's like
like
if I'm gonna hit U.S. soil,
that's true. If
it's
you're
like
in the US, you're gonna go to a lot of the US.
for broke, right? I'm gonna go for broke.
Right.
Like I wouldn't sleep for 2 weeks. It'd be like, you know.
Right.
Yep.
Someday, maybe with the kiddos in tow too. I'm sure. And Mrs. Evie, we'll get the whole gaggle of nerds here.
It would literally have to be that because I take the kids to school 3 days a week. I'm now the local soccer coach, right?
I heard about that. I saw that on Twitter.
I got roped into being the local soccer coach. I got to take them to other activities and stuff like that. There's literally probably the most I could disappear for if I timed it right is probably 2 days. Is like a day and a half, 2 days, right? That would literally be the longest I could go somewhere without having to reschedule and find get parents to help out.
Right, exactly.
Taking the kids
family,
and looking after
calling
the kids.
favors.
Yeah. It's so it's just it's silly. So people ask why I don't go anywhere. Well, then, sorry, that's why.
Yep. Oh, I'm sure people with kids understand that one.
Oh yeah. And unless you're like, then people make the argument, well, I've got kids and I go for, I'm on the road all the time. It's like, yeah, because that's your job and you're used to that. So you,
it's scheduled around it and stuff.
You organized your life around that lifestyle, whereas we're used to being like, I'm 5 minutes away, drop the kids off, So, yeah, it's a very different lifestyle thing. Anyway.
Yeah, man. Well, speaking of lifestyles, I have a new thing in my life. I don't know if you've been watching my Twitter feed, but every morning I put up a new video.
Oh, I noticed you were doing a lot of videos at the moment. You're back to a video a day. Is this a thing?
Right. So it's
why?
like
You want to build up your channel? Is it part of your course thing, or is it?
No, it's not.
They seem to be
just
just free videos.
Yeah, it's all KiCad stuff. So it's a 5.0 thing. It's videos I've been meaning to make for a while. But it's kind of like what you're talking about, like finding that time. Like you have to like find the time in the day. And so like in my morning routine now, I've just kind of got it so that I go upstairs, turn on my recording setup, and record a video about KiCad that I think about while I'm showering. Maybe TMI there. Sorry about that. But like just kind of like that's where it fits in the day before I leave for work, and so that's worked out really great. So there's a lot of...
Well, your format allows for such a thing, whereas my format doesn't, for example.
This is like the 5-minute videos that you were going to do at one point,
Yeah, those 5-minute rant videos, exactly.
Right.
Yep.
Yeah.
Like there's no reason I couldn't do videos like that. It's just that they wouldn't be the same quality of what people come to expect on my channel. Quality in quote marks,
It's the same. I think the same quality is right. They have a certain quality to them,
Yes. They're edited, and they're polished. They got like stuff overlaid on them, and they're at least a little bit polished in that. I take out ums and ahs, and I take out other pauses and stuff like that, and like with your thing you can do that because you've got the pause button, right? You just hit the space bar.
I got rid of that.
Oh, really? What?
Yeah, so now I do it where basically I just record for 5 minutes. If I get it wrong, I throw it out and just do it again.
That makes sense. Yep. I can dig that.
But it was all because there's a lot of changes. Like I kept talking to people about the 5.0 version of KiCad, and a lot of people were like, "Yeah, I didn't know about all these features." I keep finding about new features too.
Right.
And then 5.1 just just got tagged as getting released soon. So if people are interested in that stuff, there's a new version there. And then they'll start working on 6 already. So it's not fast. Don't get me wrong. It's not fast,
right.
But it's moving, and that's great. So I'm very excited about all that stuff.
Have you thought about a separate channel for that rather than on your contextual electronics channel? Is it better just to have like a KiCad channel?
That's a good question, but yeah,
all KiCad 24/7. You know, it's just everything KiCad.
I guess that would be, yeah, I guess so. I don't know.
Because you've got a lot of material that you could seed onto there, really.
Sure,
but,
sure.
The problem with that is that it's not evergreen content, some of it.
Right, exactly. And that's
some
the other
of it's
reason.
just, you know, it's how to use this new feature, and this new feature changes in the next version. Oops.
Right.
Video,
right.
you may as well remove it, you know.
Right. Right. Someone made a joke the other day. They're like, what do you need to in order to learn how to use the KiCad for layout software? And they're like, YouTube and a good internet connection, you know, like,
Right.
and that's unfortunately, like, that's just kind of the quirkiness of, you know,
Sure.
CAD programs and specifically KiCad. But yeah, it is a little different. But, you know, there's also learning. Like, I watch other people's videos about that stuff too. Like, I think you can kind of glean other methods from, you know, even when there's specifics around, you know, how to do a certain thing in a certain CAD package. I think so. Like when I watch like Fusion videos, you know, I might be watching like how to do a spline in that's not the right term. How to do like a rotated shape in Fusion 360, right? It is very specific to that release of Fusion 360. And
and it changes, does it?
That they move buttons.
Really?
Well, a lot less than they used to. From when they started like 4 or 5 years ago to now, it is very different, and I like it. But it's but then
you like the change, the things changing all the time, or you like how they do it now compared to how they used to do it?
I just like the software in general. Like I'm willing to put up with it. You know, like I have a pretty high tolerance for that kind of stuff.
Yeah.
But, you know, when I was watching people do it, it was often like, I don't need to know how to make like the spiral on a screw, you know, like that's like often the thing I'd be watching. It's like, I don't even know how to do that. And yet that's a new technique that I've learned just from watching the feature about the software. And so, I'll watch that kind of stuff. I'll watch a lot of things on YouTube, let's be honest.
Right.
I met someone the other day who said they watch chainsaw videos on YouTube.
Why not?
They just... I didn't know that was a thing. Like sometimes it's just like I didn't even know this is a thing. You know,
there's a genre for everything. Like,
I know, right?
You know, it's like, it doesn't matter what you're into.
Yeah, exactly.
Yeah, there's a channel out there devoted to it.
Yeah.
Oh, I saw it. I tweeted this the other day because I just did a free energy video, right, debunking these ridiculous scams. It's still there, by the way. Can we actually talk about that for a minute?
Sure,
it's like. Right, so I did this. People don't know I did this. We'll link it in. I did this video. It was just like actually, this was a single take video. I didn't edit this at all. Sure. It was a blab. You know, I just press record, boom, and then finished 18 minutes later. It was literally
which is short for you.
Yeah. And then I uploaded it, and anyway, there's these some viewer pointed me to these 4 Kickstarters that are basically free energy over Unity, you know, BS, right?
Yeah, and one of the ones you linked on Twitter at least was just like, it literally said like, it was like a computerized voice. It was like, free energy all the time.
Free energy, perpetual motion, infinite energy and perpetual motion, right? Yeah. They literally say it in the video.
Yeah.
And it's just like, and sure enough, right? And somebody said, look, somebody just posted on Twitter this morning, I retweeted it, that, oh, look, they were going to give Kickstarter the benefit of the doubt because the Kickstarter's so huge now that they don't have the number of people to evaluate every campaign.
That's what I was going to say
back in the old day. Yeah, you wait a couple of days and a human would eventually get around to looking at your thing and approving it. And they thought, look, I'll give them the benefit of the doubt, but I'm going to report this thing anyway. So he reported it, and he got the response back saying, oh, no, it passes it doesn't violate any of our guidelines.
What?
So perpetual motion, no problems whatsoever. Like the people reviewing these things are either so incredibly stupid they don't understand what perpetual motion is. I mean, you know, anyone with a high school level education knows what that is. Anyway,
what if they're
either that dumb
or something?
or they have to rigidly follow the procedure, and the procedure doesn't specifically exclude perpetual motion machines.
Right. So
Right?
if, like,
And-
if you
and
check all
it's
the
like-
boxes to have like description and video and all these other things,
Does it violate any of the... No. And it's from freaking Cameroon. And as you said, it's like it's half in English, half in French from Cameroon. And it's in a robotic voice. And they don't have a real prototype. Like, it's just...
maybe it's one of
just
those things too where
unbelievable.
like you know, like sometimes you only really deal with like exception reports, like, you know, if you have high enough volume. So like, so if
Right.
you look through
Oh,
like
yeah, yeah, of
compiler
course.
errors and compiler warnings, all that other stuff, you only really
Right.
give a crap when something goes wrong, right? You might
The
not check all the
errors. You only
warnings.
care about the errors. You don't care about the
Exactly.
warnings.
So like if this
know,
project
yeah.
started getting funded and then people complained about it, then you pay attention. You know what I mean? Like,
Yeah, pay attention, but it
Yeah.
only had like $10 in backers.
Yeah, I saw that. I was like,
three
oh, yeah.
backers or something.
yeah,
Right,
because
so,
I think some of that is just, I mean, it's still laughable to have that on there, but,
it's like
but at least it
nobody's
gives,
ever gonna.
yeah, exactly. It gives you something to talk about too, though.
Exactly. Like nobody's going to get suckered into these because they're so
Right.
bad that they're not going to go viral.
Yeah.
Like the Solace one did that I did a couple of weeks.
I think
did the
those
other
are more
week.
dangerous, where they're like, you
Oh,
know,
yeah.
they feel
Really
sciencey
slick
enough.
marketing.
Yep,
Yeah,
exactly.
Yeah,
Yep.
and they have really polished, slick marketing. Whereas these over Unity machines are done by some nut job in their basement, right?
Right.
And they've just put zero effort into the campaign, and it's
Yeah.
just
Well, then
and
eventually,
it's not polished or professional.
you know, you could like put some like background music to it, and it could be like a new like chill wave
Yeah.
kind of like you know, new agey music kind of thing. You know,
Yep.
free energy.
But it's about the principle of these things, that these companies
Yeah.
are so inflexible that they allow this.
I don't. I mean, like,
It's just...
I don't think that's that big a deal personally. I mean, like, I get where you're coming from, like, but I think it's just a numbers game, honestly.
Oh,
like,
yeah,
there's-
it's a numbers game to them. But they, if you cared about your reputation as a company, you would,
Maybe, yeah. I mean, you could say the same thing about YouTube, though, like, right? I mean, YouTube has so many people on it, like, you can't possibly police everything, you know? And if you did,
Oh no, of course,
I think that would be worse.
You work based on reports, and that's what you
Yeah.
should do here. But also the fact that there's not, it's not like there's thousands and thousands of these perpetual motion projects, perpetual motion campaigns, right? So
Yeah, so
it's
you're saying like
as
have
I
like a
said,
block on certain topics, that kind of idea.
well, not necessarily a block, but an engineer or at least somebody with the knowledge to review these sorts of things. And everyone said, oh, they can't afford to hire an engineer because then everyone else, because they'd have to pay them twice the amount of everyone else, and then everyone else would get jealous. And then, But as I said in the video, have an engineer on a retainer, and they do it on a case by case. Here's a new project. Oh, it's to do with they're making some energy device. Send it to Joe Bloggs, and Joe Bloggs engineer, and he'll evaluate it. And it doesn't cost much. You could pay him $100 or something, and it'd take him 10 minutes to look at that and go, nope.
Yeah.
Yeah. Like it's not hard. It's not hard. If they really wanted to do it, they could, and it's just embarrassing that this sort of stuff's allowed.
Whatever. I mean, I think it's more of a problem when it gets through. So I don't know.
Yeah. Anyway.
What's up with these? So now I'm looking at your Twitter feed. First off, I found the phrase that I was thinking of Aussie Man for, fair dinkum. I'm sure you've said it on here before.
dinkum.
Yeah.
I've said it when we were here, I'm sure. Yeah, I've said it on here all the time.
Yeah, I'm sure you
fair
have.
dinkum.
Yeah. I think of Aussie Man. Sorry, no offense, Dave. That you
No
would
worries.
post about read relays, but no, it was the chips that you bought on AliExpress. What were those?
Oh, yes, these little RAM memory, SRAM chips or whatever. Yep.
So what were they for though?
Oh, they're for a scope upgrade that I'm doing. This scope has like spare pads for these RAM chips, so you can upgrade them and you can hack the model to be an upgraded
nice.
model with color screen and stuff.
Oh, nice. Okay.
Yeah, so I ordered them on AliExpress. Foolish me thought that they'd be new old stock.
I
right?
mean,
Nice.
you can hope, right? It's usually low enough cost that it's like, I'll take a shot.
It's a low enough cost. I'll take a shot, And sure enough, they come in and they're desoldered. The pins are bent. There's shorts between, there's solder bridges between pins, and they've been like they haven't even been nicely removed from the board.
Right,
so
right.
it's like
they just like clip
they've
them
been
off.
removed on some hot plate, some like fry pan or something.
Right.
Like, so I wouldn't even bother to solder these in.
Right.
Like I simply would not trust them. I wouldn't, So yeah, unless I had no other choice and I was absolutely desperate, I'm just not going to waste my time with them.
I agree.
Just try and order some more, and I'll take pot luck again. And if they turn up looking like they're kind of new, then at least I'll So at the moment, somebody in Shenzhen is furiously trying to silkscreen on the top of the chips, the one that I actually ordered.
Yeah.
They're trying. I'll probably get fake chips or something next. It's oh god.
Yeah.
Yeah. Fair dinkum, mate.
Yeah, fair dinkum.
Yanks cannot say fair dinkum. They just can't say it.
Fair dinkum?
Yeah, it's too formal. Fair dinkum, mate. Yeah.
Got it. Okay.
Yeah.
I wanted to talk about batteries.
I've done like 20 videos on batteries. Knock yourself out.
So, how often are you doing stuff with unprotected 18650s?
I would not build an unprotected 18650 into a product.
Why is that?
Let's put it that way. Because it's unless you build the protection into your design.
Yeah, I mean that's the idea. So I basically have I have a thing where I have a cell and I have a charging circuit and it takes care of all that stuff outside of it. But
then that's fine.
Yeah.
But if it's anything, especially if it's user replaceable and stuff like that, you just like because people are buying these 18650s from anywhere in Shenzhen,
Yeah.
like the worst possible places, and you just
I was amazed. So I was shopping for them a couple weeks ago, and it's just like it's hard to find them, honestly. Like they're not like listed a lot of places. There's very few retail stores.
What's hard to find an unprotected one?
It's hard to just find the cells, honestly. Like I mean, like so,
what,
like so
18650 cells? Are you kidding me?
No, so like so let me be more clear here. I was looking at Amazon Prime. I wanted them in 2 days.
Right.
And yeah, no one has that because like they'll only ship them ground, which makes sense because it's lithium.
Right, of course. Lithium. Yep.
And then like a lot of the listings, so like so it's just like non-standard stores. So like even within DigiKey, I was looking on there, and like SparkFun sells some that they basically distribute through DigiKey. But that's some of the only cells that are on DigiKey is the SparkFun cells.
Really?
Yeah, it's surprising, right? You'd think that would be on there.
I'm stunned. Yeah.
And so it was interesting just seeing like what was out there. And so basically you have to either go to a larger distribution kind of point. I didn't go to like larger distributors like Arrow and Avnet. I didn't look at those. I was literally just looking on there. I found it. I'm done. Whatever. But like I kind of expected it to be more prevalent and it's just kind of you have to look in other places, because it's
right.
It's less of a consumer-like thing, I think. I think that's really what it comes down to.
What type of 18650s? Are you talking about the consumer ones with the nib on them, or are you talking about the tag ones?
Can you define the difference?
Well, the ones that have like a normal battery, they have like the little nib on the end that you put into a regular battery holder, or you're talking about the ones that have the welded tabs that come off and they're permanently installed inside your product.
Still the same like cylindrical cells.
They're still exactly 18650s.
Got it.
But they just have a different interface. They just have a different physical.
This is the nib, but it's not like the kind of nib that I think about for like a AA battery. It's not actually raised that much above the plastic wrapping kind of thing.
Yes, they're quite indented. Did you know that there's a length difference between the unprotected cells and the protected cells, and that can be a pain in the ass?
I figured that because where else are you going to put the protection, right? It's just like a circular board that goes on top, right?
Well, no, you can custom design your cell to make it, your actual cell to make it shorter, and then put your protection in there on top. But only your more professional manufacturers do that. If you just get one hung low brand, then it's going to be a normal 18650, and then they pack the little PCB on top, and that's why it's bigger. Right. So it depends on who you get them from, but some things just don't fit.
Exactly. If you don't have like enough give on your snap-in pads, that kind of thing.
Yeah, totally.
So I mean, this is still an early product, and I'm playing around with it too. So it's not like but like I've tried it. Today I was like playing with it. I got it plugged in, and it's all charging. It's doing fine, whatever. And I'm just kind of curious about your takes on it too, because I'm thinking about temperature differences and stuff like that too. Like, is this going to be okay in the field? That kind of thing. But
are you talking about when it's charging or when it's discharging?
Both.
Both, right?
Yeah.
So it's a fairly heavy discharge.
So I'm saying no, not the internal temperature. I'm saying the environmental temperature around it.
Yeah, right.
That kind of thing. So like does it hold up over temperature? Like, does it like capacity type stuff change at lower temperatures? Those kind of things.
Have you read the data sheet?
Some of it, yeah. I'm asking you about your, like your experience over time, though.
Well, I can't remember precisely, but the capacity can change slightly with temperature. Mm-hmm. Well, if you're talking about, a 40-degree change, right, which is possible. People think that's extreme. It's not, right? For a product like here in summertime, 40 degrees.
Oh, okay. You're saying
US
C.
in wintertime, it's minus 10.
You're saying C. Yeah, I was thinking, the day we recorded.
Oh, yes. Sorry.
When we recorded the other day, or like a couple weeks ago, that Set Fire to the Tracks episode, that was minus 30 C, and today it's about 10 C. So it's
insane.
It's about 5 C today, so 35 swing. So
in those sort of temperatures, like everything matters. Your LCDs stop working. Right.
Because the liquid doesn't flow, or what?
The liquid crystals do not flow. Go and take your multimeter or some other product, whack it in the freezer for half an hour, take it out, and then look at the update rate of the screen. Look at the update rate of the LCD. The numbers will change very slowly because the liquid crystals are, starting to freeze up in there, and they just can't move fluidly. So your update rate goes, crazily slow on your LCD. So basic stuff like that, you just can't rely on things to work. So it's kind of a big deal, but which is the big difference between designing a product that's designed to be used like outdoors or whatever, and one that's designed to be used in like a lab environment, and things like that. So but sometimes you don't like care about that. You just go, well, it is what it is, right? If it doesn't work down at minus 10 or something, well, sucks to be them.
Yeah.
Right. So like you can't cater for like everything. So you can, but there's a lot more engineering effort that goes into it, and a lot of the time, like for example, this Micro Supply that we're doing, right? Yep. It's designed to be portable, obviously, and like it could be used in minus 20, but are we going to like design it around that? Well, no. In fact, we haven't even tested the LCD down at 0 yet. So I don't even have the capability to. Well, no, I could whack it in a freezer, I guess, but I don't have any controlled capability to do that here. So it's Yeah,
you need like a cycling oven or something like that. You're saying?
Well, you need an oven that goes below. Well, you need a thermal incubator.
Right.
That goes below 0. And like I've got my little thermal chamber here, but it only goes down to about 5 degrees thereabouts. Depending on ambient temperature.
Because your heat exchanger, you basically need like a heat exchanger that's pretty beefy to keep going down below that.
Yeah, it's not great. So if I want to go below that, basically I have to whack it in the fridge, really.
Yeah.
And it's anyway. Yep.
Okay. So no other thoughts about unprotected cells in general?
Well, so is this going to be a consumer?
No, this is all industrial.
This
is industrial.
So. Oh, in industrial. Well, no.
Nothing I do is consumer.
Okay. well, like in theory, I probably would recommend using a just basic engineering. Safety principles. You would use a protected cell because you can.
Yeah.
Right. And
well, there's cost differences.
Probably no reason to. Right. Because something could go right. You've got your hardware. You've designed that in. That's fine. But what if your hardware fails? Right. Mm-hmm. And then it shorts out. There's nothing to limit the current coming from that cell.
Yeah.
Right. There's nothing, and that's what the protection circuitry does. But then you can argue, well, the protection circuitry could fail and short out. Right?
Sure. Yeah.
Okay. It's like, yes, sir, it's turtles all the way down, right? It's like...
Right. Well, atoms, quarks could reverse polarity and, they can implode upon themselves.
Right. So, it's turtles all the way down, and I would do it, right? Because generally, like, especially if you buy a quality cell, if you buy a quality Panasonic cell or something like that, or some other name brand, and they're going to have name brand, qualified protection circuitry in there, right? It's just one less thing for for you to be concerned about. I would certainly do it. There's a lot of energy in lithium batteries. They're freaking dangerous.
Oh yeah, they are.
Right? They're just no. I would do it as a matter of course. You know, if you deliberately, just simply from a liability point of view, right? You've considered this and you've discussed this publicly.
Hey man,
and then
this isn't out yet.
Made the deliberate decision, engineering decision, to not go with a protected cell, and it melts down. You're liable for that.
Yeah.
Whereas if you used, a good engineer, if I was an expert witness in court, if I was called against trial against Christopher J. Gemmell.
Oh man, yeah, right? Dave is. We now call Dave Jones.
We now call our expert witness to
fair dinkum testimony against Christopher J. Gemmell.
That's it.
Yeah.
And I would say yes. A good engineering practice would dictate that you would choose, unless there were mitigating reasons that you needed that you couldn't use it, size, other requirements of efficiency loss or whatever. There was some other engineering reason why you didn't have it, why you couldn't have that protection circuitry. Then good engineering prudence would dictate that you would choose to have it. Yep. And if you deliberately decide it just because sounds like a heap of shit, right? Couldn't be bothered or whatever, right? You're going to be liable.
Right.
That's a thing, right?
Yeah, that's a good point.
So, so yes, use your protection circuitry.
Yeah, well, I was thinking more on the cell side versus on the the circuit side. So that's I'm
talking about the cell side. I'm talking about the
double redundancy in that case.
Oh yeah,
right?
yeah. You wouldn't design your own. I mean, you can buy qualified little boards that you put in line with the battery, especially if you've got like the tab wired batteries, and then you could wire, and then you wire it in series. You can buy qualified PCBs that actually protect your product, but you wouldn't necessarily go design that on your PCB. I don't think you could, but it's just an extra layer of when you can buy a cell that's already protected and qualified.
Right. Yep.
Extra thing you don't have to worry about.
Yep. Good thinking.
Basic. I don't know why you even asked a question, quite frankly.
Got to talk about something here, Dave.
Obvious.
Come on, man.
Right, yeah. We have to fill the time in. Yeah.
I mean, the other thing, too, is that...
As I said, there are legitimate reasons there why you would choose not to, right?
Okay.
Deliberately not to have a protection device in there. So it's something that should be discussed.
What would be some of the reasons not to in your mind?
They would be, as I said, a space requirement. If you're designing an ultra low, like a volumetric efficient product, like a little watch, for example, watch is not a good example because they've got such low capacity batteries anyway.
Right.
I don't know. You've got you've got like an iPhone or something, which is a real high capacity, dangerous battery in there, but you were so packed for room that you just couldn't add it. You just couldn't add the protection circuitry for some reason. That might be another reason. There might be discharge reasons.
I guess that's not a user serviceable either, right? That's not a...
No, it's not. It's not user serviceable. So, maybe you might choose not. I mean, you wouldn't in a consumer product selling in the millions like that. You'd be like crazy not to, but of course, because then you end up like being Samsunged, right? Where their phones just catch on fire. But they caught on fire internally where the external protection circuitry didn't matter, right? So that was another turtle down.
That was a space thing, right?
Right, that was a turtle, but 2 layers below your other turtles that you're dealing with.
Right.
I'm telling you, it's turtles all the way down.
Yep.
And so that protection circuitry did squat. Yeah, it did squat.
Yeah.
So then, what do? Add protection layer, but add protection circuitry on individual layers.
Right.
It's kind of what they do in the Tesla. Once your solution gets technically big enough, like a car, like a Tesla car, right? They've got individual cell protection, then they've got group cell protection, then they've got major group cell protection, then they've got entire pack protection.
I didn't know
that. They've got
that.
protection up the wazoo, right? Because you have to. It's just crazy. Well, I'm not sure if they have... they must have individual cell protection. I think they do. But I know that they do have and then string protection so that a string can go and it protects the string and then it, and so on and so forth. And yeah, it's crazy. And then there might be a leakage issue. I know that, lithium's got, well, it doesn't have like low leakage, like, it can last for a year or two, right, on one charge. But like leakage might be a problem, for example, perhaps. I don't know. If you had an ultra low leakage cell that you were trying to use, then the protection circuitry might take a microamp or two, right? And that's constant leakage that you don't want, for example.
Right. Yep.
You can, yep.
Yeah, because it's powering, like it's got like a resistor going to ground or something just to watch and have a FET that activates or something like that.
Like the gate of the tranny's got to be pulled up to,
right.
I don't know, right? Who knows? I haven't looked at it for years. But yeah, like it is non-zero. It's non-zero. So.
Yep. Cool.
USB 4. What's this shit about? I haven't heard about USB 4.
That's just a new spec. So basically, if you have a Thunderbolt device, so like the laptop I'm actually recording on right now is a Thunderbolt device, and basically Intel opened that up, and then that got adopted as the USB 4 specification. So it looks very similar to USB-C. It is a USB-C connector, but then it has like the little like lightning bolt looking thing on it.
Okay, so it's backward compatible with USB-C, because the last thing we want is yet another bloody connector.
Yeah, but it is different though. There's like, I don't know, there's a bunch of weird stuff. So like my laptop connects to my external graphics card and all my monitors through that, and then it has like Ethernet. Yeah. So like that's kind of like the bandwidth it can do. So like my laptop can drive a video card that drives 3 monitors and then has an Ethernet connection through it at like 10 gig, and it's like okay.
Crazy.
That's a lot of, but every time I plug it in, it pretty much crashes the computer. So there is also
really?
that.
Okay.
Yeah, it's real finicky. So
got it.
I don't know. We're just kind of reaching speeds and like obviously it's amazing what is possible, but it's like the speeds that they're reaching are just insane.
Yeah.
Crazy. I don't know what this means for us. It's 40 gigabit per second. So like, you need special transceivers for that kind of thing. It is type 3, you have to do a bunch of weird stuff there. I still haven't, I don't know, have you put any USB-C stuff on boards yet?
Yes, the new Micro Supplier uses.
Oh, it does, okay. But are you using it in USB
yeah.
2.0 mode, or are you using the newer, higher speed?
We're not using high speed. It's incredibly low speed. In fact, we could have used USB 1, right? It's like, it's that low speed. It's like 115K. Bits. It's like serial info. It's just serial, basically. Yep. So it's nothing. We're only using it for its physical robustness and for its power capability.
Yeah, exactly. And I think that is that's the other people that I've known who've been doing it. Like I know some people who have built with it, and it's for the power stuff, and then the higher speed stuff was not really a concern. It's the you talked about making that one prototype unit, soldering it yourself. That's going to be fun. Those connectors are not fine pitch.
No, they're a pain in the ass. and we talked about the original goal was, look, we're going to have multiple connectors on there. We'll have Type C, we'll have micro, we'll have mini B for, keep everyone happy. And ultimately we decided, no, it's just stupid. We'll just go for Type C because you can buy a little adapter that converts Type C to micro anyway. So you just supply that with the product. You can buy that in bulk for like 10 cents from AliExpress or whatever. So, you might as well throw a couple of those into the package. It's just, so we just went with the Type C.
Yep, that's good. So, I think that's smart.
Yep.
I mean, conversion is that's on other people. Mini Bs, come on, man, who's using mini anymore?
Mini Bs, there are a lot of Mini B fanboys out there.
I mean,
they swear it's the most robust thing.
It is
ever,
very robust, but it's pretty
I don't
big.
Know. It's not pretty big. Mini B, it's not that big.
Double the height of a Micro B,
No, yeah, but when the physical plastic around the micro connector is bigger than the Mini B, then right. Come on, you're having a bit of a wake there. Not being fair dinkum, mate.
Right, not being fair dinkum.
Dinkum. Oh boy. All right, we're almost out of time.
Yep.
We're almost out of capacity. What else we got?
I don't know.
Grab your tickets for the CAD conference.
Oh yeah, that's good. Yay. That's coming up. Looking back through my my tweets here, I guess sorry you weren't here last week, but we did talk about graphene last week. I know that you've also talked about. I did mention you.
Right.
Yeah.
I haven't heard the episode. So
your
you talked about graphene.
Yeah.
What did you talk about? What did you say about graphene?
Oh, because Sam, the guest, used to be a researcher with graphene. So he was doing like nanotubes.
Right.
Or wait, was it nanotubes? Maybe it was
Right.
graphene. I don't know.
Yep.
Something carbon based.
Right.
And yeah, so we were talking about all that stuff and how it transferred. He's now doing perovskites and printable solar cells. So it's pretty cool stuff. Cool episode.
Excellent. But it still doesn't magically produce
It
heat
does not.
from no input. No.
No.
So did you actually discuss that on the episode?
No, we didn't go that deep.
Right.
Yeah.
But obviously it doesn't.
Right.
Yeah.
Actually, here's one last thing. This is just a little bit of like engineering porn kind of stuff. I'll send you the link real quick. This is someone who MG on Twitter is doing PCB stuff with a mill, but there's solder mask involved, and so it's fine enough pitch that they're milling off the solder mask, and then it's just exposing the copper beneath it, and it looks really good. And so you can go back through their tweets and like the
To what end? To what end are they doing this? What's the
making PCBs at home.
So it's one big no. They've got like this existing layout board.
Mm-hmm. So they applied the solder mask on top after doing the actual milled PCB piece, and then they're milling out the solder mask to expose the copper beneath it.
Oh, okay, right. So they milled out a PCB, they milled out the copper, then they applied solder mask at home, do it yourself, and then they're milling out the solder mask.
Yeah.
How do you mill out the solder mask without
very carefully
damaging the copper? Is my first question.
That's the idea. So like, think about how much vertical height control you need to have to just get that layer off.
Ooh.
Yeah, it's very impressive. Go back through the tweets. It's very impressive work.
Right.
So like, if nothing more than just as an exercise in making
of course,
beautiful PCBs.
Yeah.
So
it's maybe not a practical solution.
No,
but
I mean milling in general is like, but if you're going to use this process, like, applying solder mask is awesome, right? That's usually one, aside from just the size constraints of, milling, if you get a good mill, usually then the solder mask is kind of the next thing that you want to have some kind of insulation between your part and your board. So it's great.
Yeah, and I guess it makes sense. If you're a milling person, you've already milled out your PCB. You don't want to get the chemicals out and do your photo imageable solder mask, right? That's just kind of defeating the purpose. So you want to mill that too.
Yep, that's right.
I guess.
Yeah.
Otherwise, you'd photo etch your boards as well. You wouldn't mill them. You'd photo etch them.
Right, exactly.
So, cool. You don't... It's got to be taking some of the extra copper off, surely.
Oh, probably, yeah.
Yeah, but who cares,
way,
right? As long as it doesn't eat through it all.
Yep, exactly.
But yeah, the tolerance, because the 1 ounce copper is how many microns? It's like 5 microns or something.
No, more 5 microns?
Sorry, 50 microns.
Is it that low?
50 microns or something. Yeah.
Not 50 mil? You sure?
Yeah.
That doesn't sound right. Micron's pretty small, Dave.
Hang on. 35 micron. 1 ounce copper is 35 microns.
Really?
1.4 mils. Yes. 35 microns of copper.
Wow. Okay.
Yeah, it's not much. So if you take off, you have to not take off more than a few tens of microns.
Wow. Yeah, that's pretty down.
That's how precise it's got to be.
Yeah.
Right?
Unless got a thicker. maybe there's thicker boards too. So.
Well, you can get 2 ounce copper. Woohoo! You go up to 70 microns.
Yeah.
You're still down in the sub 100 micron region.
Yeah, that's crazy.
Imagine, just the flat. You would need your bed to be that flat. You'd need your bed to be flat within tens of microns.
Yeah. Oh, yeah. I have no doubt this is very dialed in.
Wow. No wonder nobody's done this before, because they just go, well, my bed's got to be flat within 10 microns. Bugger that.
Yeah, right.
Right. It's just pointless, even to try it. But hey, hats off, right? They did it. Okay.
Yeah.
Wow. Oh dearie. All right, groovy. Anything else?
No, that's all for me, man. I'm back to making sure I don't explode batteries on the bench. So.
Use the protection circuit.
Yeah.
Unbelievable.
All right, man. Talk to you soon.
Catch you next time.